Good morning, afternoon, evening, wherever you may be. My name is Dr. Nicholas Adjabu. I'm the head of the biomedical engineering unit of the Ministry of Health in Ghana. And I am the coordinator of the project that worked in partnership with Delft to implement the X-ray diagnostic images. The project name was the Accelerating TB Case Detection, and this was funded by both the government of Ghana and the Dutch government. Can you scroll? Okay. So in terms of my presentation, I'm going to give you an overview of the systems that were introduced as a result of this project, the reasons why we implemented the project, and also tell you some of the benefits and the outcome we have so far achieved. Ghana is a country in West Africa, surrounded by Cote d'Ivoire, Burkina Faso, and Togo, and in the southern part is the Atlantic Ocean. The population is around 30 million. At a point, you know, TB screening using ionizing radiation was stopped because of the challenges that ionizing radiation had on the human health, and the challenges using the analog system. So with improvement in technology, introducing the digital system, the use of X-ray was approved for us. So in 2009, we had two measures. One, our TB detection was not very good, but the treatment success was quite high. And put them on treatment, not only will we be saving in terms of cost, but we'll be able to halt the transmission as well. The other aspect was that number of our hospitals were without diagnostic X-rays. So we put the two together and made a case. Sorry, there was you can hear me now?
Yes, I can hear you now. Thank you.
Hello. Okay, all right, okay. So in terms of the project, we have to look at strengthening our health system, and at the same time, working to improve the TB management in Ghana. Along the line, there was a delay because of the funding, so we actually started implementation of the project around 2016. And during the waiting period, we had the opportunity to, actual prevalence of TB was higher than what WHO estimates given to Ghana was. And therefore, we had a real situation revealed to us. We incorporated a number of technologies, because one of the challenges was that we had limited radiologists to even read the images, and therefore we needed to look at the improvement in the IT system, the communication, information technology systems in Ghana, and link our X-rays up. The good thing is that because it's digital, you could easily transmit images over any network, and therefore we're able to do that. The other component that was introduced was the use of artificial intelligence software called the CAD for TB to also help detect or suspect those with TB. As part of gene experts, we're able to improve our case detection. So in terms of the project itself, as I said, our aim was to improve the case detection from as low as 35% to about 85%, which was the target agreed on with WHO, were to be enrolled on so that any TB can be detected much earlier than waiting till it gets complicated, and then treatment can start early. And also attempt to halt the spread of multi-drug TB. The other benefit of the project was that a number of our hospitals were not having diagnostic X-ray machines. So through this project, we had 52 hospitals being enrolled onto this. So our diagnostic imaging system received a boost. And with the transmission of images, they were able to link up with radiologists in regional hospitals and teaching hospitals where they need any assistance to help them interpret the X-ray images that they capture. We are yet to receive the final impact report from the TB control program, but a number of things has been achieved. So far, hospitals are able to have access to the diagnostic X-ray. They are able to reduce the cost of the diagnostic X-ray. You know, those that we replace were analog systems. So you have to do this dark room, the chemical processing of the films that will be captured. And in that case, the chemicals were into the environment, which was also not, the cost of the films and the chemicals was another cost to them. But with the digital X-ray, errors were reduced. You have the digital image, which you can save to a pen drive or CD, or even transmit to another user over the information technology network. So in actual fact, a number of benefits were achieved. The TB control program also received the mobile X-ray, which we installed in a mobile van, 2 of them. And then we had a backup, which they could also use in case they need to visit places where the van cannot access. And they are able to organize a district widening. So they go in a district and have arrangement with them and just screen the community, especially the vulnerable groups. We have a number of categorization of the vulnerable groups, including minors, including those with HIV, those with diabetes, and so on. The schools, at the beginning of the academic year, they are supposed to have a screening done. So once they go, they are able to screen quite a number of students, and those that have the TB are picked, and further investigations are made to confirm whether it's actually TB or not. And then those that are confirmed, they are put on treatment. The other benefit that we had was that we had a challenge in some of the locations putting up a complete housing unit for the X-ray. In that case, we adopted the container system, and we also have occasional challenges with the electricity supply. So we needed to have a backup, not only to ensure continuous supply of electricity, but also to have to protect the equipment against any voltage fluctuation. So some of them were able to connect the power system to solar. So some of the X-ray systems are purely powered by the solar system and not depending on the national grid. And those that were installed in buildings or housing units were connected to the national grid. So that was one major improvement, because solar to drive X-ray machine is an advanced technology that not only saving in the area of the purpose for the X-ray equipment, but to also save on energy and also contribute significantly to the reduction in green gases release. So we have some data of what the systems that were installed have been able to achieve. From 2016 till date, data has been captured. We started having a stable data capturing from 2018. So 2018, 2019, when the assessment was done, the various modalities per administrative region were analyzed, and putting them all together, we realized that the first group, which was 2018, 2019, were able to capture 130,324 images. And there has been a consistent growth in the numbers of the X-ray images that has been captured. The data is further analyzed, and there is a graph. If you can go to the next slide to show the utilization and the number that has. So on the right, year on year, each region, the number of images that are captured. But I must say that the regions do not have equal numbers of expo. It's just to give you an idea what is happening in there, but it's not a uniform data that you can say that a region is doing well or not, but per each region, the number that they have, what they were able to capture. And on the left is the cumulative. To make TB assessing the X-rays very comfortable to have TB. The containers were painted by artists to depict some local cultural information, and that made everybody more comfortable going there. So there is not only tagged as TB. The other thing is that everybody goes there. It's not only TB. The most important thing is that you go there for your X-ray. So when you go in there, it could be TB, or you may have other problems that require X-ray imaging. So people with fracture will go there, people with spinal problems, with suspected TB or even confirmed TB. Everybody can go there, pneumonia and all sorts of cases. So these are some of the pictures of the containers, depending on where they are located. And thank you very much for the opportunity to share with you some of our experiences in Ghana. I will be leaving for another program, so I don't know if there is anything I can throw light on quickly, and then I can move to my next program. Thank you very much.